Hello everyone, I am Shravani Padman and my presentation topic on experimental validation of strain distribution using strain gauge. What is a strain? Is a device to measure a stress to validate the theoretical stress distribution in a structural member. For example, beam, plate, shaft under a loading condition by using a strain gauge. To measure a strain, compute the corresponding stresses. What is a stress and strain? When material subjected to external force and internal force, stresses developed to register deformation. Formula of a normal trace. Normal trace is denoted by sigma. Sigma is equal to pressure upon area. Pressure and force upon area. Bending trace. Sigma B. Sigma B is equal to moment into neutral axis. Why means neutral axis upon inertia. And third one is a shear stress. Shear stress denoted by tau. Tau is equal to VQ upon IT. Strain gauge principle. A strain gauge is a resistive factor whose the electric resistance changes with a mechanical deformation. When strain is applied, the relative factor is equal to gauge factor upon E. Sorry, into E. Apparatus. Mild steel or aluminum beam plates specimen, electrical resistance and strain gauge. One element or three resort. Wheatstone bridge circuit. Strain indicator data equation system. Loading frame. Dial gauge. Dial gauge is optional. Power supply connecting leads. Apparatus means what needed to practical is, uh, is a part of apparatus. Experimental setup. Well, first of all, clean prepare specimen surface, mount strain gauge using the adhesive, connecting gauges with Wheatstone bridge circuit, calibrate the instrumentation, apply loads incrementally, and record the strain readings, measure deflection. Then procedure. Measure the specimen geometry. It means a specimen length, width, thickness. Second one, strain gauge at a critical point. Third one is a connect strain gauge to indicator. Apply load in step. Record the readings for each load. Compute the stress using the sigma is equal to E. Compare with the theoretical value. Plot trace versus load curves. Then after that simple calculation, measure the strain. E is equal to 250 into 10 raised to minus 6 microstrain. Microstrain is a unit. Young modulus. Young modulus denoted by E is equal to 200 GPa is equal to 210 raised to 9. PA means Pascal. Unit. Pascal is unit. Trace. Trace is denoted by sigma is equal to n modulus is equal to 200 into 10 raised to 9 into 250 into 10 raised to minus 6 is equal to 50 MPa. Compare with the theoretical bending traces. Sigma B is equal to moment into neutral axis. Neutral axis upon inertia. Result and discussion. Plot load versus strain and load versus stress graph. Experimental curves should the approximately linear. Means curves should be linear. Compare the major stresses distribution with theoretical prediction. Possible discrepancies due to imperfect bonding. misalignment, or non-uniform loading. Application. Application means what is what apply. This a strain gauge, structural and mechanical design verification, calibration of a finite element model (FEA) validation, stress analysis of bridges, design the bridges, aircraft. Aircraft is wings flexibilization, pressure vessels, fat- fatigue and failure, investigation, and real-time load monitoring. Conclusion. The experimental result closely matched the theoretical stress distribution. Strain gauge proved reliable for measuring strain, demonstrate linear relation between load and strain. Proper installation and calibration are critical for accuracy. Thank you.